Oh, you did.
All right, welcome back from spring break. I hope you recharged a little bit. I just had our TA meeting and we're all kind of bemoaning the break a little bit because it gives us a glimpse of like a lifestyle we feel like we should be living, and then we have to return. Who knows the answer to this? Some of you? What is it?
It's ITS.
ITS. How is that? Someone else tell me why it's ITS.
The order of the first letters on the top.
So the sentence asking the question is G, the next 3 letters. So it's the acronym of the sentence, basically, right? So, all right, good for you to pick those out. Did anyone else have any different answer? Magically come up with something?
TUT.
What is that?
TUT.
TOT, how'd you say that?
TUT, because like, so G is 7 letters from the beginning, N is 14, L is 20, or wait.
So you did a bunch of math and kind of came up with some patterns there.
Yeah.
All right, for the assignment that's due end of the week, it's a pretty straightforward assignment, except you have to mess around a little bit with some syntactical Java kind of stuff, right? So basically you have to make a generic class from the one I give you, which is the same one you used before, essentially. And you need to inherit from it and override the way the array grows. So there's just there's 2 steps, and both of them are pretty short, really, to be honest. But you can, of course, get yourself, do some wrong syntax and kind of end up wondering how to fix it. So give it a try. Make sure you can get to the basics pretty early. I did have a mistake on there, trying to turn that generic thing in. I was reordering code and broke some stuff. And so anyway, if you didn't see the updated code or the announcement, take a look at that. It just was not working correctly if you're inserting things early in the array. So any questions on the assignment? Yeah.
So the third part, can you give us like a hint of where to start?
The third part. What was the third part again? I'll write a new one. Okay, so the question is, there's make the class generic, inherit from it to make one that doubles, is that the one? And then make your own growth strategy. There's actually, I'm not really looking for anything fancy, but I'm hoping in some ways that you come to some realization that doing one thing, more of one thing makes it faster. That's all I'm really looking for. So don't do any super complicated, don't do anything super complicated. I just want you to kind of realize there's something you can do to make things faster, but there's a cost to it as well. And don't panic about it, I guess. Just come up with something dumb, and you'll be fine. If you come up with something super awesome, let me know. We'll write a paper about it. But Okay. Let's talk about inheritance again, since that's part of the assignment, right? And this week we're going to be doing more with inheritance and why it's useful. So some terminology we call it the superclass. And the superclass is the parent of the derived class. And so you would inherit from the superclass to make the subclass. And in Java, we use this extends keyword. So you're saying that the subclass extends the superclass. And you can override methods in the superclass. So let's do a little quick coding just to kind of refresh our memory on this. So I'm going to make a car class. And I'm going to have a private instance variable, and let's see, for a car, let's talk about its horsepower, basically how powerful the car is. That's all we care about, right? We don't care anything else. We just want to show off our mighty car. And I'm going to make a public car constructor that takes in a horsepower, and we're going to set the instance variable horsepower to be that passed in parameter. So when we construct a car, we say I want a car with 100 horsepower, and it makes a car with 100 horsepower. And I'm going to make a RunEngine, and doesn't take any information. It's just going to print out some silly message that we know is doing something. So I'm just going to say put put. I have horsepower. All right, and then that's all finished off. And so if I want to make a car, I can say I want a car type, and my car equals a new car with 50 horsepower. And if I use my car to run engine, it should print out that message. All right, so if I run this, put I have 50 horsepower. That lack of a period is kind of bugging me. So I'm going to add that in there. Okay. So this is, just a normal class, right? It has one instance variable, a constructor, and a method that does something. And then we tested it here in main. So I want to now make a car that inherits from this. And so let's add a new class to here. And I'm going to make a new class. And let's make this a specific kind of car. All right, Camaro. Always been my dream, right? So, public class Camaro, we're going to say it's going to extends from car. So once I say that, what do we get from car? So you said horsepower. We get the instance variables, but we have storage for the instance variables. They can't actually directly access horsepower because it's private. Now in your assignment, I made like data protected, in which case the class that inherits from this can use that instance variable name directly in there. But again, we're typically kind of cautious about making things even protected because it can break encapsulation of the class, allow people to do things to the class we don't expect. So even though I have storage for horsepower, I can't really get to it directly here. So if I wanted to make a Camaro, I can't say horsepower equals 500 here. It's going to say it's not visible. Field car.horsepower is not visible. What's it complaining about here? Implicit, okay, it wants me to construct the parent class. How can I get this horsepower set? So in here I set it through the constructor, right? But I can't set that instance variable directly, so what can I do?
You can make a setter in the car class.
Okay, so I could make some sort of setter here to say set horsepower, and then I could do that. There's another mechanism already available to us here. Yeah, so I want to call the car constructor from this constructor, and I'm going to do that through super. So normally super, that would call a default super constructor. If I don't have a default super constructor, I have a car constructor that takes one parameter, and so I can put in a value here. And that 300 gets sent to here, and then this constructor assigns that to horsepower, and so I can kind of initialize it properly in this sort of multi-stage approach. I want you to keep in mind, when you inherit from something, you're not only sort of setting up yourself, but you're setting up the class that you inherit from. And the right way to do that is through this the parent class constructor. And we call that through super here. Okay, so just keep that in mind. When you start inheriting, it kind of adds like more bookkeeping to building up these classes. So a question about that one little thing there. It's an important thing. So I want you to kind of see that pattern, right? When you're inheriting, you start kind of thinking about these things a little bit. Okay with that? So if I were to make a Camaro, my car equals new Camaro. Now notice I'm not passing any values in here. I'm sort of saying a Camaro has some set engine, which probably isn't true, right? That's always going to be 300 horsepower. And so that builds. Now how can I see what's in here? So I can say my car RunEngine because I inherit that RunEngine from car, right? So RunEngine is a public method in car, and so when I inherit from car, I get all the public methods sort of for free, right? That's part of the fun of inheritance. Now it's not perfect because now if I were to run this, putt, I have 300 horsepower. That doesn't really make any sense anymore, right? Like 300 horsepower is beefy, and so it would not be putt. I need some other way of saying something. So what can I do? Well, I could have in here probably, not in here, in here, more like an if statement saying like if my horsepower is less than 50, say putt. If it's between, 50 and 150, say per, or something like that. And then if it's, mighty like the Camaro, make some other message, right? But maybe I don't have rights to be messing with this code, so I need to do something else. So instead, I can override the inherited RunEngine. And again, normally we don't like having duplicate methods that have the same name and the same parameter list in the same class, but in this case, because I inherit from it, you're allowed to do this overriding process, even though its signature, the top line here, looks exactly the same as the one in car. So in here, I can drum, look at me. And I don't even have to say my horsepower because we know it's mighty. All right, so vroom, vroom, look at me. So now this method takes precedence over the one in car because it's defined in the same class as Camaro, right? So it looks first in the class for methods, and then if it doesn't find them, it goes up and looks for them in the superclass. Now there is this one notation that we like to put on overrides, override. And again, the point of this is, if I run it, it does the same thing. It doesn't seem to help me at all. But let's say I try to say run the engine here. Like I used a different name. And it's going to say here, in tiny letters, the method RunEngine of type Camaro must override or implement a supertype method. It's basically telling me, I believe I'm overriding what I thought was RunEngine in the car class, because I was mistaken in the name. But instead, I'm creating a new method in the class that is not actually overriding something. It's its own independent method, right? And so this override tag here, annotation, basically checks and says, are you truly overriding something? Because you seem to think you're overriding something. And if you're not overriding something, you're confused about what's going on. So this is just a little further sort of sanity check about whether, again, in this sort of more complicated inheriting world, whether or not you're doing the kind of things you're thinking you're doing. Yeah.
And it's that override notation
that's what.
that's
So if
causing the check.
If I get rid of that, this is perfectly legal.
Gotcha.
But of course, I'm not actually overriding at this point. I'm just creating a new method that's sort of the same, kind of close in name, right? So it's just a way of making sure there's consistency in what your mental model is of what's going on between this inheritance of the superclass and the derived class and what's actually going on here. So it is good practice from, again, it seems a little pointless. It doesn't make your code run faster, better, or do anything like that, but it's good practice from just sort of like a large system point of view If you think you're overriding something, add this overriding annotation.
So the methods need the same name in order to override?
That's what overriding means. Basically, you have a method of the same name in the derived class as exists in the superclass. Okay, so questions about that? Kind of good? So anyway, your mental structure gets a little more complicated with inheritance here. You need to kind of step up to the, the complexity level a little bit. And it's going to get more complicated. All right, so let's run a little Kahoot. In 2, 9, 0, 6, 3, 1. Go ahead and log in. And if you need a device, I have one more device up here. The joys of the $20 tablet. I don't feel like anyone's going to be too desperate to steal that from me, so. Let's see. All right, almost logged in here. So I'm going to ask you a few sort of more design kind of questions. Here's something I want you to do. How would you do it? And it's going to sound kind of vague. You know, a lot of our questions on Kahoots have been like specific. Tell me what comes out of this Java stuff. To be honest, that's the stuff at some point you got to just assume people know how to do. And at work, it's going to be more like people say, hey, I want you to make a class that does this. And you have to kind of think about how you structure that kind of activity. And so these design questions are actually really the hard part about development, and we need to sort of practice that a little bit. So, a lot of little words here. How would you do this? Given a mouse class, let a cat object chase that mouse object. So, I'm giving you a class already, a mouse class. You have to write a cat code of some kind, and it's supposed to chase this mouse object, and there's different sort of strategies for letting those two things connect together here. Okay, so let's start the questions. So we want cat, chase, mouse. And I hope I clicked the right answers for these. I was, once again, trying to type over my cat. Talk to your neighbor about it a little. Seven seconds. Okay, so a lot of opinions here. So we're going to write a cat class. It's probably going to have some sort of chase method, I would expect, right? That's how you make objects do things, is you write methods for them. And the question is where it interacts with this mouse. So one possibility is making a mouse object, an instance variable in cat. When you say that, what are you kind of saying about the relationship there? So what does it mean to make an instance variable in another class? There's a little phrase that should go through your head in some ways that we've been talking about.
Has a?
Yeah, so that would say that a cat has a mouse. And maybe it does have a mouse, but if it's chasing it and kind of killing it, it probably doesn't have it for long, right? So there's no reason to kind of track that mouse from inside the cat. And maybe you want to have different mice the cat can chase. And so to sort of stick one mouse in there doesn't make full sense. I mean, it's available to the cat if it's an instance variable. It's like, you know, it's going to be there. But it's like you don't want to clutter up your class with every little thing it interacts with. Make mouse a parent class of cat. If it's that relationship, again, what's the little phrase we use to describe that relationship? You would say a mouse, or a cat, what of a mouse? There's a little, so the instance variable, what we call composition, is has a, and then
Is a?
the inheritance is a. So you're saying a cat is a type of mouse. And that's not true, right? A cat is not a type of mouse. And in fact, for then the cat to inherit all the methods of mouse are sort of weird, right? Like I would then say the cat has availability a squeak squeak method, and a cat has a live in a hole in the wall method kind of thing. And a cat is none of those things, right? So that's not quite right. This was the correct answer. Make mouse a parameter of a cat method. And again, I'm thinking the cat is going to have a chase method. And what is it going to chase? It's going to chase a mouse. And so at some point you would send to that cat method, the chase, the mouse that it's trying to chase. And then the last one, make a cat a parent of mouse. That's saying a mouse is a type of cat, and that's not true either, right? So I know this question's, it's a different style of question. I'm not surprised that people were trying to have a hard time figuring out what I was trying to ask in some ways. But again, this is the kind of stuff that is more real to what you're trying to do. Your boss is going to say, hey, we got a cat robot and it's chase a mouse. How are you going to do it? And you got to figure out the relationship between these things and write the code part is supposed to be the easy part. It's design that gets a little tricky. All right, questions on that before we try another one? All right, so, and that's what when we see your code, it's like, it's this sort of, I'd say, uncertain decisions about how to structure these things that we see a lot of, and it's just practice, right? You just have to get used to doing it. All right, so next one. Given a mouse class, write a pet mouse class. About 10 seconds left. Okay, so pretty good. You guys did a good job on that one. So when you're thinking about class hierarchies, the superclass is what should be the general type of thing, like the most abstract, the most general. And then the derived class, derived or subclass, gets more specific. All right, so it has some more narrow scope. So you're going to take the general stuff from the superclass and then add in some more details for this derived class. So in this case, it's not that a pet mouse has a mouse, again, right? That's not the right relationship here, and that's what we're saying if you made it an instance variable. Make mouse a parent class of pet mouse. So that's the correct answer. And because a mouse is a more general form, we want to inherit some general kinds of things from mouse, but pet mouse would add something like a name or something like that, right? So the pet mouse class would get all the other stuff, behaviors, and then it would add like a name instance variable and some other, look for pets from your owner kind of methods or something like that. Again, the parameter one, it's not clear what kind of action would be needed for a pet mouse to know about a mouse. And then this is reversing the relationship here. And we're not saying that a mouse is a type of pet mouse. We're saying that a pet mouse is a type of mouse, right? So you have to kind of get which one is the parent, which one is the child class kind of straight in your head to get that one working correctly. So questions on that? Next question. Give it a mouse class, write a mouse cage class. A mouse cage, I mean, like, you know, someplace for the mouse to live. Mouse house, we should call it mouse house, be a little nicer about it, you know. Mouse prison. What's going on here? Almost out of time. All right, so most of you picked the first one. Someone tell me why you picked the first one.
Yeah, because
Hey, quiet down, please.
because a mouse cage can have a mouse.
Yeah, a mouse cage has a mouse, otherwise it's not really a mouse cage. It's just a cage, right? And so you can imagine a mouse cage would have a mouse instance in it, and it would interact with that and somehow, you know, do stuff for the mouse. Provide a feeder bottle and all that kind of stuff. So there's not an inheritance relationship here because, again, a mouse is not a kind of a mouse cage, and a mouse cage is not a kind of a mouse. You could maybe argue a little bit for the third one, make mouse a parameter mouse cage method, but I think they have a closer relationship here, right? That we're actually, the mouse cage and the mouse are kind of tightly intertwined, and they're going to interact a lot. So it's not just like one temporary method that's going to interact with that mouse, but instead we're going to hold that mouse inside us and be, you know, work with that one pet over and over again, not keep passing it in to mouse cage methods every time we want to do something with a mouse, right? So again, you know, these are all decisions. It's like you could write code that would make all this work. It would do something, so you can make it compile and run and probably even solve the problems you're trying to solve. But some of them are awkward interpretations of how to structure this related code, and some are more natural ways. And again, more you start to see these things and able to make sort of better choices, the better your life is as a developer, because things will just more naturally be solved instead of you fighting stuff every step of the way, kind of thing. All right. Questions on that? Other questions though? So just, you know, keep realizing different ways to solve problems, and some maybe a little better than others. Now, let's talk about shapes for a second. So some shapes you can imagine: circles, rectangles, squares, triangles. How are they related to each other? What do they have in common? What's different? So let's common things, different things. So if I give you a circle and a square, and I say, what's something we can talk about in common with these two things? What's something we can talk about in common? You know?
Both have sides.
They have sides, and what's something we can measure about those sides, maybe?
Side length.
So, okay, so and what's the side length of a circle? I don't know what that is, I guess. You know?
That would be the perimeter.
Okay, yeah, perimeter. Yeah. So someone else said circumference, but again, for a square, you don't really talk about circumference. You talk about the perimeter. How long, if you march along with all the sides, what does that add up to, right? What else?
Enclosed space. Like a volume, if you will.
Yeah, so for 2D stuff, we'll talk about its area, maybe, right?
They are both two-dimensional and made out of X and Y.
Yeah, okay, so they live in some sort of space, some 2D space, maybe. What's different about them? I mean, obviously they're different, otherwise they'd both be called square, right? So, there we go.
How do you find
Okay, the math, the formulas to figure those out are different. So, I mean, they're related, right? But the specifics are different. That's good. That's close enough. Right? What, here's something else.
Probably just like number of corners.
So yeah, like
The circle would have none, and you would.
they both have corners, but again, the math is different, kind of, right, on them. So let's write some. So there's some common stuff, and again, when there's common stuff, you start thinking about inheritance, right? And there's some different stuff. So like at least overriding is going to be important. But how would you structure the relationship between, you know, a square and a circle? Kind of like we were talking about before with those Kahoot questions. So if there's some inheritance relationship, like which one is the superclass here? Would you pick square? And then this is like a more specific kind of square? Or would you pick? So we're kind of stuck here a little bit, right? There's not a clear answer as to which one of these is sort of the more general one. So instead, we're going to introduce sort of an artificial layer, shape, and make circle inherit from shape, and make square inherit from shape. Okay? Now, is there such a thing as like, well, I mean, sorry, is there such a thing as a shape? Like if I give you I said, I have a nice shape, tell me its perimeter, do you know how to do that? Not really, right? So in some ways, this is a very general and very abstract kind of version of stuff. In fact, we don't even know how to implement it in some sense. So Java lets us do this kind of building up relationships where one of them is sort of a very general kind of thing. So let's write some code. And let's see, let's write a circle first, I guess. Oops, okay. Okay, so here I have a circle class. And what does a circle need to know about itself to compute like these kind of those area and all that kind of deal? It's radius, yeah. So let's do a private double radius, and let's construct our circle. Public circle, and we're going to pass in a initial radius, and we're going to set that radius instance variable to be the initial radius, and that's sort of good enough. Well, let's make a little output kind of deal. So we'll do a public string to string, and in here we want to print out something about its area and radius, maybe, because that's what we can compute. What's the complaint about here? Must return something type string. I know. Okay. So I'm going to return its area and get area. So we need to compute that somehow, and perimeter. Get the perimeter, and that should be enough to do that. But the problem is we don't have those methods written, so we need to write a public double get area, and its area is math dot, is it capital pi? Yeah. Times 2 times radius squared, right? Radius times radius. All right, so we have a radius, and We also want the perimeter along with the area. So get perimeter. And that is pi 2.0 times radius, right? And if I run this now, make a circle. Circle, C1 equals new circle with a radius of 10. And if I say print my circle, then we'll see what comes out. Let's run this thing. Death dying, what did I do? Some problem here. Return, area, get area. Oh, I was pretending that was part of a system out thing, so. Okay, so lots of big numbers there. That worked out fine. Now let's do the same thing for square. And then kind of clean this up a little bit. So, or we'll do rectangle, I guess, because that's what I already started here. What does a rectangle need to know about itself? How do you define a rectangle? It's yeah, it's width and it's double. It's width and its height, right? Width, private. So notice it doesn't share like data with the circle, right? They hold different things. One holds a radius, one holds these two numbers, so they don't even have that much in common. And I can make a public rectangle constructor with double init width and double init height. And I'm going to set those width equals init width and height equals init height. And I need to compute its area, so we keep cranking out all our little code here. Double get area, and we're going to return the width times the height. All right. And again, some of you are still. This method accesses the instance variables of the object, and some of you are still want to pass in, this kind of thing. You're trying to give the information to the method because you're used to the methods having to take in all the stuff they work on, right? But that's not the object-oriented approach. Instead, there's a particular rectangle that calls this area, and it accesses the stored width and height that are stored in that instance. And so we're not giving it any extra information here. Public double get perimeter, and I'm going to return 2 times width plus 2 times the height. Okay, so we define get area, get perimeter. Now what do I need to write for its toString here? Notice this toString would work over there because I'm calling this get area and get perimeter. I'm not trying to do the math inside the toString, right? I'm not trying to send out radius either. So if I were to do this toString and make a rectangle R1 equals new rectangle with width and height, and I run this, rectangle. I was feeling so good about myself there. Man. Nothing happens. I didn't do anything. So print.
All the toString.
Yeah. R1. Okay, so that works. Now, there's an opportunity here to put these into more of a cohesive relationship. Okay, so we have our rectangle that has its own unique width and height, but then has this get area and get perimeter that are in common with this other thing, the circle. And the circle also has the get area, get perimeter, and they both have a toString that actually happens to be exactly the same. And so we want to somehow show that these are related a little more closely than we're doing right now. Right now in our minds, it's like, okay, a circle is related to a rectangle, and they both have these same methods, and they both have these same ways of interacting with them. But that's in our mind. We want to make that explicit in the code by the way we design the system, so other people see that relationship as well. Otherwise, they're kind of guessing, like, does this person think the rectangle and the circle are kind of related? And if I make my own other shape, what do I have to do to make it seem related to those as well? So we're going to define a shape class and inherit from that in our other classes. So for the shape class, what do we want? We want this, we can actually, let's use this toString. We're going to say that's going to be a common feature of all our shapes, that it can print out something with its area and perimeter. What kind of instance variables do I want in this shape class? Do I need a height, or a radius, or a... Come on, you know shapes. What does a shape have? It doesn't have anything, right? We don't know what it is. It's just some abstract thing. So we're not going to have any instance variables. And in fact, if I wanted to have a... what am I doing here? Good thing I looked down for a second there before I... We know we want a shape to have a get area, but what area does a shape have? Right? We don't know. So what's going to happen is we're going to make this called what's called an abstract class. An abstract class defines certain methods that classes that inherit from it should have, but it doesn't actually implement itself. And it's just an organizing tool to say, these are things that all these derived classes should have in common. So the way you do that is you add this abstract keyword, abstract. So we're saying this abstract class contains methods that must be implemented by derived classes, but we don't provide any implementation ourselves. So when I have an area one, I'm going to say that this is a public abstract method, and in this class, I just say it exists. Not here, but in a derived class. All right? And same thing with, I did there. Get perimeter. Perimeter. All right, so this is kind of weird, right? I'm saying here's a class. It has these methods that I don't give actual implementations to. But if you inherit from me, I want you to provide them. It's sort of a contract between groups of classes. So it's a way of me saying, I believe all shapes should have a get area and a get perimeter, and I'm going to enforce that by saying there's these methods that you have to implement. Now notice up here, I can still use get area because it sort of knows it's going to exist at some point when we actually implement this thing. So let's go back to circle and actually use this thing. So public class circle extends shape, and same with rectangle. Rectangle extends shape. And what's this? This is, okay, so if we have this method defined in the superclass, so we don't need to provide our own toString because it's the same code in both circle and rectangle, that they both have the exact same code, and so they can inherit from shape and use that method that's inherited. All right, so if I were to run this, let's see what happens. Okay, so it still runs through some miracle, right? So what happens? We inherited from shape. All we get from shape is the toString method, but we also get this idea that we must implement the get area and get perimeter. So if I don't implement that, comment out that block, and I try to run this now, it says the type rectangle must implement the inherited abstract method shape get area. All right, so I can't even, once I extend shape in rectangle, I cannot even not, I have to implement that method. And so again, I'm enforcing this rule in my design of the system. I'm saying I want all shapes to know how to print their, area and print out their perimeter, or calculate those things. And if you don't have it, you don't belong to this family of shapes. All right, so it's me enforcing a certain vision of what a shape means. And again, that may not seem like a big deal, but all of a sudden you have a whole bunch of classes and the relationships are not that clear. It's nice to have these sort of, these more general things that kind of say, hey, if you look at this, this tells you everything you need to know about everything that inherits from me. We're going to have a get area, we're going to have a get perimeter, and we know how to print ourselves out. And so, again, it's a way of understanding larger chunks of the system kind of more easily by looking at this one kind of cleaned up thing. But it is kind of weird that you can make a method that doesn't have code in it, right? So just kind of step over that and try to accept it as a tool for your use when you're designing these larger systems. So, and oftentimes, of course, a class like this would have even more methods that are sort of generally useful to all those shapes. Like maybe you'd have a collide function or something that says whether you're colliding with something, and it would know how to do that kind of thing. Now, in here, I should use that override annotation again to show that I'm overriding, even though it's still an abstract method, not implemented, I'm still overriding it and providing an actual implementation here. And so it's good to know that we're overriding that abstract class one. And you have to get used to the syntax here, that up here we have abstract in the class name, and then abstract on the methods that aren't actually implemented. Now another detail is that you can't actually make a shape object. It doesn't really exist because those aren't implemented for it. So if I were to try to make a shape down here, shape thing equals new shape, it's going to complain and say cannot instantiate the type shape. As soon as you have an abstract method in there, you can't make one of those objects. So again, it seems even weirder. I'm making a class you can't make code for, or you can't make an object of, but it has an organizational tool in a larger system.
How come you didn't make the toString method in the abstract class abstract?
So in this case, it was the same code for both the derived classes. And so I could implement it here and it still works. Right? There's no specialization that has to happen in circle for that to be true. There's no specialization in rectangle. Now if I wanted this toString to print out my radius, I would override it and make my own toString in circle. But I'm sort of saying, in general, I want shapes to print out their area and their...
So they do the same thing, so you don't need to make abstract.
If it does exactly the same thing, you can put it in the superclass and inherit it in the derived classes. Okay? Question?
Can you do kind of a combination of both? Like,
well, this is a combination of both.
so you know, like if just speaking of the toString, like if you wanted to add radius in circle, could you inherit that toString and also add radius?
So I could, let's override this in circle. How would I want to take advantage of this kind of thing, right? So I don't want to I don't want to replicate that code. So I would call super.toString to get the basic part and add in, and my radius is plus radius. All right, and now if I run this, it works in this case. I didn't have to still customize it in this case. It still just uses a more generic shape one. Well, whatever I did some this thing. So you can selectively override it in derived classes, right? You don't have to, if you do it once, you don't have to do it in all of them. You can use the abstract one, or you can use the more abstract one or the specific. All right, so recognize this. This is, again, I think a more complicated concept. It takes time to kind of like internalize and want to use, but it's an important concept in Java inheritance. Bye.